Chemistry chapter 21 theory video 6. Now we are going to look at how to make a buffer solution. So obviously we know that we can make a buffer solution by adding a weak acid and its conjugate base, or a weak base to its conjugate acid. So we get the pH that is required by adding these in different proportions. So then what we need is to prevent a change in pH. If the acid and conjugate base are more concentrated, it would have a better effect, or it would be more effective in preventing a change in pH. So the higher the concentrations, lesser would be the chance the pH would change. So if you take 50 cubic centimeters of 0.1 mole per cubic decimeter ethanoic acid into a beaker and add a spatula full of sodium ethanoate into that and dissolve it, we will get a solution of the weak acid and its conjugate base. So then what we do is we add a few drops of universal indicator to give it a definite color, and then using a color chart we measure its pH, or else we can use a pH meter. Then when we name it as a buffer solution, we take a sample of this we take a sample of this buffer solution, and then add hydrochloric acid, small amounts of hydrochloric acid with very little. Slowly we add. Then what happens is we will actually observe later on that there wouldn't be much of a change when you keep on adding acid. There wouldn't be much of a change in the colors. So here, from point 4, we can move on with a different aspect. That is, we take 1 drop of 1 mole per cubic decimeter hydrochloric acid and 50 cubic centimeter distilled water. Then what we do is we take this second beaker, that is hydrochloric acid, which is going to be a strong acid, and we dilute that acid until you get the same pH as the buffer solution, that we prepared earlier. So then what we do is we mark it as unbuffered solution. Then what happens is we add sodium hydroxide to each of these beakers. What will happen is the pH level will quickly change in the what we added in the hydrochloric acid sample, but it wouldn't change that much in the buffer solution. Hope that makes sense. Write down a note on this. To prepare testing buffer solutions, a buffer solution can be prepared by adding a weak acid to its conjugate base, or a weak base to its conjugate acid, until the pH that we require is reached. Example. Now you will have to write these details, but we will summarize it. Add a sample of ethanoic acid into a small beaker. Mix sodium ethanoate in it. Add a few drops of universal indicator until it reaches a definite color, and determine its pH. This is the buffer solution. Leave a line and write. To a second beaker, add a very small amount of hydrochloric acid and dilute it until it reaches the same pH as in the buffer solution. Label it as unbuffered solution. When sodium hydroxide of similar concentration is added to both of these, the buffer solution will show less change in color, whereas the unbuffered solution of hydrochloric acid would change color rapidly. Right. So now we are going to figure out what are the uses of buffer solution. Now, for example, our blood is a buffer solution, because if something gets added, every time it gets and something gets added, if the pH was to change, then it is going to be a problem. So to maintain maintain our pH levels, there are many buffers in our blood. So to keep the pH levels in our body parts, in various parts of the body, we have to have a proper pH level. So in humans, the pH is maintained between 7.35 to 7.45 used in different buffers. So the examples for buffers are hydrogen carbonate ions, HCO3 minus ions. These are also known as bicarbonate ions. Then hemoglobin and plasma proteins, dihydrogen phosphate, H2PO4 minus ions, and dihydrogen phosphate, HPO4 2 minus ions, dihydrogen phosphates and hydrogen phosphate ions. Both of these are used as buffer solutions in our blood. So if there is a problem in our body, we will be able to figure that out by by testing our blood for its pH. For example, we know that carbon dioxide is a product of aerobic respiration. Then carbon dioxide will combine with water in the blood to form bicarbonate ions or hydrogen carbonate ions with hydrogen. So this is this particular reaction. So now you know from where we get hydrogen carbonate. There is an enzyme called carbonic anhydrase which catalyzes this reaction. When hydrogen carbonate ions go through the small blood vessels around the lung, it will be quickly converted into carbon dioxide and water, and then carbon dioxide will escape into the lungs and out to the body. So the production of H plus ions the H plus ions will remain. Then if that is not controlled, then there would be a situation called acidosis, which will actually which will be an accumulation of acid, and that will lead to coma and death. So the equilibrium between carbon dioxide and hydrogen carbonate is going to be a very important buffering system in the blood. So when what happens is, when H plus ion concentrations increase, the position of the equilibrium will shift to the left. As a result, more H plus ions will combine with HCO3 minus ions to form carbon dioxide and water until equilibrium is restored. So that will reduce the concentration of hydrogen ions in the blood and leaves it constant. If there is if the H plus ion concentration decreases, then the position of the equilibrium will shift to the right, because that means there is more carbon dioxide and water. So then what happens is, some carbon dioxide and water will combine to form H plus and HCO3 until equilibrium is restored. So this will increase the hydrogen ion concentration and keeps it at constant level. I hope that makes sense. Please write down a note. Buffer solutions have many uses industrially as well as biologically. Example, electroplating, manufacture of dyes, and treatment of leather. In humans and other animals, maintenance of blood pH is carried out by using different buffers in the blood. Example, hydrogen carbonate ions HCO3 minus, hemoglobin and plasma proteins, then dihydrogen phosphate H2PO4 minus ions, and hydrogen phosphate HPO4 2 minus ions. The carbon dioxide that is produced by aerobic respiration combines with water to produce hydrogen carbonate ions and H+. This reaction is catalyzed by carbonic anhydrase. When HCO3 minus reaches the lungs, they will be converted to carbon dioxide and water back again, and carbon dioxide will leave. So this buffer maintains the pH of the blood. Write down this equation. CO2 aqueous plus H2O aqueous, giving you H plus aqueous plus HCO3 minus aqueous. Then write down, if H plus ion concentration increases, equilibrium shifts to the left, more H plus combines with HCO3 minus ions to form carbon dioxide and water until equilibrium is restored. This reduces H plus concentration and maintains pH. If pH increases, if H plus ion concentration decreases, position of the equilibrium shifts to the right. More carbon dioxide and water combine to form H plus and HCO3 minus ions until equilibrium restored. That is, more H plus is produced. So as a result, H plus is maintained. This increases the concentration of H plus and maintains the pH. So if you ever become an anesthetic if you become a specialist in anesthesia, then you would know how to maintain the pH, or you will have to check for the different changes that happens in the patient. Please do question number 11 if you have understood. If you have not, please raise questions.